Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel, and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Welcome to today's tutorial on Apache VXQuery, an open-source system designed for querying massive XML datasets efficiently. As part of the Apache Incubator project, VXQuery aims to bring the power of XQuery, a W3C standard language, to big data environments. It is particularly useful for organizations dealing with structured and semi-structured XML content at scale. Before diving into VXQuery itself, let's briefly cover XQuery. This is a standardized query language specifically designed for extracting and manipulating XML data. Similar to SQL for relational databases, XQuery allows developers to write declarative queries over XML documents, leveraging powerful constructs like FL-where expressions. VXQuery stands out because it enables scalable processing of XML data using distributed computing. Unlike traditional XQuery processors that run on single machines, VXQuery can process terabytes of XML data by leveraging Apache Hyracks for cluster coordination and resource management. At its core, VXQuery consists of several key components. The XQuery compiler parses and optimizes queries, while the Hyracks runtime engine manages distributed execution. Integration with HDFS allows seamless access to large XML datasets stored in Hadoop clusters. Let's take a closer look at how VXQuery works under the hood. First, the XQuery is parsed and compiled into a logical execution plan. This plan is then optimized before being translated into a physical plan for distributed execution across Hyracks nodes. Apache Hyracks plays a critical role in VXQuery's performance. As the runtime engine, it handles task scheduling, data shuffling, and fault tolerance across a cluster. Its modular design allows for fine-grained control over parallel execution strategies. The XQuery compilation process in VXQuery involves multiple stages. Starting with parsing, the query is converted into an abstract syntax tree. Then, semantic checks ensure correctness, followed by optimization steps such as rewriting and cost-based planning. VXQuery uses advanced optimization techniques to improve query performance. These include pushing down predicates early in the pipeline, reordering joins for efficiency, and leveraging indexes where possible. Cost-based optimization ensures the most efficient execution plan is selected. VXQuery seamlessly integrates with HDFS, allowing it to read and process XML files stored across a Hadoop cluster. This integration enables efficient data access patterns and supports a wide variety of XML formats commonly used in enterprise settings. In performance benchmarks, VXQuery demonstrates significant advantages over standalone XQuery engines. Its ability to scale horizontally means larger clusters lead to faster query execution times, especially when dealing with complex nested XML structures. One compelling use case for VXQuery is in digital libraries, where vast collections of XML-encoded historical documents require fast querying and metadata extraction. VXQuery enables librarians and researchers to perform cross-collection searches with high accuracy and speed. In scientific domains, VXQuery excels at handling structured outputs from instruments and experiments encoded in XML. Researchers benefit from its ability to extract meaningful insights quickly, supporting both real-time monitoring and retrospective analysis. Enterprises often store content in XML-based systems like CMS platforms. VXQuery helps organizations process these exports efficiently, enabling tasks such as compliance audits or migration projects with minimal downtime. To get started with VXQuery locally, you can download the binaries from the Apache website. After configuring your HDFS settings, you can launch a local Hyracks cluster and begin executing sample XQuery scripts to test functionality. For production use, VXQuery can be deployed across a multi-node cluster. This involves installing Hyracks on each node, defining the cluster topology, and deploying the VXQuery job controller. You can monitor progress and resource usage via the built-in web interface. Writing your first XQuery in VXQuery starts with mastering basic syntax like FLWare expressions. Use XPath for navigating XML structures, apply filters with where clauses, and aggregate results using group by for comprehensive data insights. To maximize performance, understanding how VXQuery executes queries is essential. By leveraging indexes, rewriting inefficient queries, and applying partition pruning, you can significantly reduce execution time and resource consumption. VXQuery includes robust debugging and profiling tools to help identify bottlenecks. The Hyracks web console provides real-time monitoring, while detailed logs offer insight into query execution performance and resource utilization. While VXQuery offers many benefits, it does have limitations. The smaller community compared to SQL-based engines can make troubleshooting more challenging. Additionally, users need strong XML knowledge, and the tool isn't suited for purely relational datasets. When choosing a query engine, it's important to compare VXQuery with alternatives. While Spark SQL handles mixed data types well, VXQuery specializes in XML. Compared to native engines like Saxon, VXQuery scales better but requires more infrastructure. As an Apache incubator project, VXQuery has active mailing lists and a growing GitHub community. While still maturing, enterprises can contribute directly or seek commercial support through vendors familiar with the technology. Looking ahead, the VXQuery roadmap includes enhancements in optimization algorithms, cloud-native deployments, and support for real-time XML streaming. Community contributions will also help expand documentation and educational materials. To dive deeper into VXQuery, start with the official documentation and explore XQuery tutorials. Familiarity with Apache Hyracks will also enhance your understanding. Consider attending workshops or online courses for hands-on experience. Ready to try VXQuery? Begin by ensuring Java and Hadoop are installed. Download the latest VXQuery release, configure your cluster settings, and execute your first XQuery to see it in action. To achieve optimal performance with VXQuery, preprocess your XML data for consistency, partition appropriately, avoid redundant joins, and profile your queries regularly to identify areas for improvement. Security is crucial when deploying VXQuery in production. Ensure proper authentication mechanisms, encrypt data in transit, configure secure HDFS access, and audit query execution logs for compliance purposes. Common issues in VXQuery deployments include class path misconfigurations, memory limits, HDFS connectivity failures, and query timeouts. Addressing these requires careful attention to logs and system configurations. In academic research, VXQuery has been used to analyze large corpora of scholarly XML publications. Researchers extract citation networks, track metadata trends, and automate literature reviews using scalable XQuery processing. Financial institutions use VXQuery to process regulatory XML filings such as XBRL. This allows automated compliance checks, structured data extraction, and audit trail generation, improving both speed and accuracy. In healthcare, VXQuery supports the analysis of HL7 formatted XML health records. This facilitates clinical decision-making tools, patient data aggregation, and improved interoperability across systems. VXQuery can be extended through custom user-defined functions UDs, new parsing modules, and API integrations. Developers can also contribute enhancements back to the open source community to drive innovation. Maintaining a VXQuery deployment involves using the Hyracks console for monitoring, setting up alerts for anomalies, scheduling maintenance, and implementing robust backup and recovery strategies for data integrity. VXQuery integrates with business intelligence tools by exporting results in standard formats like CSV or JSON. JDBC drivers enable connectivity with platforms like Tableau or Power BI, allowing for rich visual analytics. Deploying VXQuery in the cloud offers flexibility and scalability. Use managed services like AWS EMR or Azure HD Insight, containerize with Docker, orchestrate with Kubernetes, and auto-scale based on query loads for optimal efficiency. To evaluate your VXQuery setup, run benchmark tests using XML workloads similar to TPCH. Measure throughput and latency, compare different cluster configurations, and identify performance bottlenecks to optimize further. To recap, VXQuery provides full XQuery compliance, leverages distributed execution through Hyracks, integrates with Hadoop, and excels at handling large XML datasets. These features make it a strong choice for XML-centric big data applications. Apache VXQuery is a powerful tool for scalable XML analytics, offering standards-compliant querying in distributed environments. Whether you're in academia, finance, or healthcare, VXQuery can transform how you process XML data. Join the community, contribute, and don't forget to like, subscribe, and share your thoughts in the comments below. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.